Welcome to Weld.com. We've been getting a lot of requests for hard surfacing, and there's a lot to go with that. So we have some preliminary discussion here about what hard surfacing is, where do you use it? Well, it can be, number one, it's some kind of an alloy. We're putting it down for impact resistance, for abrasion resistance, both. You're talking higher carbon steels, manganese, vanadium, chrome, nickel, some combination, high manganese. So, maybe we're digging in gravel. Maybe we've got some impact that we need to take care of on a bucket or a blade or something that we're working with. Maybe we're digging in sand or something, So we need abrasion resistance. There's so many combinations when you start talking about hard surfacing. I think some of you have seen some equipment like a 966 cat front end loader where you've got a bunch of X's welded on the bucket. There's a reason for that. The X's would be to absorb the material itself and use that as a abrasion resistance, plus whatever you're putting down on there. And there's a lot of different methods that you can use to put it down. Stick welding, very common, portable outside. We're on a piece of equipment, we're not going to bring it in the shop. You got all types of alloys and rods that you can run on it. Well, one method that I want to use today is called a eutectic torch, superjet torch here. I'm not advertising this by any means, but we have it here at the college. We teach with it. We repair cast iron. We blow these powders on here. This powder is for abrasion resistance. Okay, so I want to show you something here. I've taken a mild steel coupon, one of our beveled plates, and I've taken a mill file here, a fine file, and I'm actually filed into this, okay? And I can cut this with the edge of it. It's fairly soft when I get into it. I want to warm this up, and I want to blow some powder on here, and then I want to do another file test. What I expect to happen, what I want to happen is I'm not going to be able to make this V-notch out here on this beveled edge that doesn't have a face on it, and I probably won't be able to get into the beveled surface itself, which I have cut both of those with the edge of this. So let me get some gear on. I'm going to switch this, or I'm going to leave this over here so you can see it, and I'm going to switch over on this side and do my test over on this end of the coupon. So let me get my gear on, I'll be right back. Okay, I'm gonna light up here. This thing acts just like a brazing torch. I've got a lever back here, but it's not for oxygen at all. This is essentially like a welding tip. Okay, I'm running the same pressures as I would with a brazing tip. I'm gonna try to get a neutral frame. This is one of the smaller tips. I've got some larger ones. So I want to warm this part up. I want to get it up to about 800-900 degrees, and I want to push the lever here and drain some powder down into the flame, and you'll see a difference in the color of the flame. It'll kind of a sparkly. So looks like we had some residual powder in there already. So right now that looks like a normal flame, okay, and we're neutral. So I want to start warming this part up. I am going to put my dark shield down here in a little bit. I'm going to work off of this corner. Remember, our other corner is one that we file cut. I also want to get on the back side of this, away from me, right on that sharp edge too. I want to put a little powder down on that. Starting to see a little color differentiation here on the very edge of this, starting to turn cherry red if I leave the tip on it. This torch is also very useful in blowing a nickel powder down on repairing cast iron. Okay, we're starting to show red here, so I'm going to stop with that. I'm going to let this cool off for a while. I don't want to just go quench it because that would be kind of cheating, but I'm going to let this cool for a little bit. I am going to cool the rest of it off when it comes down to a lower temperature. And then I'm going to redo the file test. I probably need to put this in a vise so I can really kind of get into it. I didn't have to over here per se. I was able to kind of handhold that one there and get into it with a file. But I want to try to get into this with the edge of the file. I don't think I'm going to be able to. I hope it shows a fair demonstration of this particular powder being on this surface as being a abrasion resistant or a hard surfacing. So let this cool off a little bit. I'll be right back. Welcome back. I went ahead and cooled this off a little bit. We had blown this abrasion resistant powder down here. On this side we didn't do anything. We had got into this with a fine file, able to cut into the edge of it, in the surface of it, up here in this corner, coming off the bevel. On this side that we blew the powder down on, I'm not able to get into it at all. I mean, you can probably see this in the light here. I had this in the vise and I was really trying to get into it with the edge of the file here, like I did here. I could feel this kind of get into it and make that cut. Over here on this side, I'm just kind of gliding over the top of it. I'm not getting into it at all. So it did its thing. It's an abrasion hard surface. So there's other tests that we could do on it, maybe a hardness test, a Brunel or something. But again, you know, you can feel this. It gives you a good indication that we're not going to get into it. You know, what could we use this for? Imagine this, you know, quite simply, how many times do you sharpen your lawnmower blades during the season when you're mowing? You know, if we went in and put this on the bottom side of our blade, didn't do anything to the top side, you know, the soft top material is going to wear away. It's going to sharpen itself all summer long. Think about that for a second. I mean, that would be one application, simple, that we could relate to. Again, there's other methods of putting this down other than the torch. The torch is not going to be effective for being outside and doing something on a bucket. You know, that's where we're going to run electrodes. I've got a Certanium 767 in my hand here. It's a, you know, it shows some. I don't want to say I can see anything in the core wire. I think that's more leftover paint. It's an 1/8 inch rod. I've got a 1/4 inch rod here that is a Certanium 425. I'd have to look these up. I don't have any specs with me as far as what they have in them, but just the core wire on here looks like it's got probably some molybdenum nickel to it. Anyway, I don't think I'd want to be welding uphill or overhead with this rascal here. This would be more of a flat application. So again, a lot of methods here. You know, hard surfacing covers a big array. It's kind of interesting too, because you get into a lot of the applications of, you know, what are we digging in? We're digging in coal, we're digging in gravel, we're digging in sand, mud. You know, what are we doing? So if you do a little research, again, there are multitudes of maintenance alloys out there. Personally, I was involved in sales, and one of our products was MG or Messer Gresham, Studi, Neptune. You've got all these different combinations, and a lot of them work extremely well. So a little research on your particular application. We use this for doing some repairs. One of the other applications for that torch is putting the cast iron powder down, repairing some cracks and stuff. So again, I hope this helped. Make sure you subscribe to the videos. New videos come out each Monday. Thank you.